Alright, today we're going to revise about discriminants and nature of roots. Now, what do we actually use discriminants for? Basically, when we have a quadratic equation of this form, where we have ax squared plus bx plus c, we can tell how many solutions we can expect to have by using the discriminant, which is this. Alright, so this is the discriminant. D equals to b squared minus 4ac, and this actually came from the general formula. So if you look very carefully, right, so this part here, this is where your discriminant is. Alright, the one that was under the square root sign. So just by using that, we can tell whether we have these three cases, right? Firstly, we can determine the nature of roots, means what kind of solutions do we have? The first type of solution would be what we call the real and distinct roots. Now this means that we have two solutions that are different from each other. Now, you may not understand what this means, so let's look at quadratic equation. So let's just say that we have x squared minus 7x plus 10. Alright, so when we factorize it and we solve it, we find that x equals to 2 or x equals to 5 are the solutions. So these are different solutions and there are two of them. So this is actually what I mean. So this is by solving, right? Then we discovered that we have two solutions that are different from each other. The numbers were not the same. We could also use the discriminant method just to find out what kind of roots we have without actually solving it. Alright, so in this case here, we have d equals to b squared minus 4ac. So a is 1, b is negative 7, and c is 10. Alright, so putting that in, we have 9. So since the discriminant is a positive discriminant, we can also say that these are real and distinct roots. Alright, so this d that is positive tells us that we have two different solutions. What they are may not be important, so we may not necessarily need to know what the values of x are. We just need to know that there are two different solutions. Alright, now it also could be used to prove that we have real and equal roots, alright, or to show that roots are equal and there are two of them. So this is what we call two solutions that are repeated. Now how does this go? Again, let's look at the quadratic equation. X squared minus 2x plus 1 is 0. Factorizing them, we'll get x equals to 1 or x equals to 1. And you realize that, hey, I have two solutions, but they happen to be the same number, which is 1. So this is what we mean by repeated roots or equal roots. Alright, the values are the same. So this is again by solving for x. Now, what if we do not want to solve for x, we just want to find out what kind of solutions we're going to get. So in this case here, we are back to using the discriminant again. D equals to b squared minus 4ac. So this is your a, which is 1, b, which is negative 2, and c, which is positive 1. So putting that in, we find out that 4 minus 4 is actually 0. So my discriminant is 0. So whenever I use the discriminant and I find that the value is actually 0, I can say that I'm going to be able to get this kind of solution, alright, real and equal roots, even if I do not solve that. And the last case would be if I have no real roots. So no real roots means I will not be able to solve for x. So for instance, we have this one here, 2x squared minus x plus 1. You could try to use the general formula, and even if you key into your calculator, somehow along the way you'll find that it will give you this message called maths error or something like that. It just means that it is not possible to solve it. So how do we show that it is really true that we can't solve it? Alright, so again, we can use the discriminant. D equals to b squared minus 4ac. So b is negative 1, a is 2, c is positive 1, and we will end up with negative 7. So this will be a negative discriminant. So when we have a negative discriminant, it means that we have no real roots. Alright, so the usual way of solving won't be able to give us any particular answers for x. Alright, so in the graphical way, how does it look like? Alright, so for the third case, right, it could be something like this, where you have a curve that is actually kind of like floating above the x-axis. So because the curve doesn't cut the x-axis at all, there are no real solutions, meaning that you won't be able to get any x values that can be solved by letting the curve cut the x-axis. Right? So this was the first case. This was the third case. B squared minus 4ac less than 0. There are no real roots. Alright? Or we could also have a case which was this one here. Remember, it was a repeated one, x equals to 1. So you could have actually touched x equals to 1 at this particular point here. So it is kind of like the curve is resting on the x-axis at one point. Alright, so this is what we mean by the roots are real and equal. Okay, so your discriminant is equals to 0. And of course, we have the third case, alright, like the one we had earlier on. So x could have been 2 or x could have been 5. So when we have a positive discriminant, so we have a case of two roots, alright, they are different from each other. Okay, so this is where we have the roots are equal and real and unequal, or real and distinct. Now, this is just to tell us about the nature of the roots, so what kind of roots that we have. So basically, again, there are 3 different types, alright? Okay, the second use of discriminants, right, is to determine the number of intersections between 2 graphs, if any. Alright, so let's just say that we have fx, so it's just a function graph, it's a quadratic graph, and gx is a straight line. You can refer to the diagram here. When we equate the two, meaning that we start with the y, we can form a quadratic equation of this form here. Alright, I will be showing you in a very short while. So similar to what we had earlier on, we can have 3 cases. Alright, we can have a discriminant that is positive, a discriminant that is 0, or discriminant that is negative. So like just now, alright, when it is a less than 0, there was no real solutions for x, right? So in this case here, where we actually solve it, it just means that the curve and the line do not cut each other, no intersection points. Or we could also have a discriminant that is equals to 0. This means that the curve and the line will touch each other at one particular point, right? Okay, one particular point, and this is a tangent line. So one intersection point, but it's a repeated solution in a way, alright? And for this case here, b squared minus 4ac is greater than 0. It just means that the curve and the line will cut each other at 2 different points. So if you get a positive discriminant, you are expected to have 2 separate solutions, alright? Okay, so let's have a look at a particular question here. So we are going to try and solve for, we are going to determine, whether the line will actually cut the curve. Okay, so this is the line and this is the curve. Sorry, this one should be the curve. Okay, determine whether the curve intersects the line y equals to 3x plus 1. Alright, so what we're going to do is that we're going to write out the 2 equations first, just like how you normally do for a simultaneous equation. Y equals to 2x squared plus 5. Let's call this equation 1. Y equals to 3x plus 1. Let's call this equation 2. So we're going to sum up the y and leave it in terms of all x only. Alright, so normally for simultaneous equation, we will start with the non-linear and we sub into the we start with the linear and we sub into the non-linear. So this is the non-linear one, this is the curve, this is the line. Alright, so we're going to write sub 2 into 1. Alright, so we sub this in. So instead of y, we have 3x plus 1. Okay, as you can see, the y has already been subbed out. And we're going to rewrite this in the form of ax squared plus bx plus c. Alright, so we're going to arrange it in this way. So let's bring every term to the right. And this is what we'll have. 2x squared plus 5 minus 3x minus 1. So tidying it up, we have 2x squared minus 3x plus 4. So if you don't like it this way, we can just write out as 2x squared minus 3x plus 4 equals to 0 is still the same. Alright, so from here we have a is 2, b is negative 3, and c is actually 4. So how do we actually determine whether the curve cuts the line? We can use the discriminant. Remember that we actually did earlier on. So our discriminant is a general form. So d equals to b squared minus 4ac. Because we do not know which kind of roots we're going to have, right? Or what kind of intersections we're going to have. So we're going to use the general form. From here, we put the b value in, the a value in, and the c value in. Alright, so when we expand this out, this is 9 minus 32. This will give us negative 23. So we have a negative discriminant here. So what we can write is that since d is less than 0, okay, it's negative, the curve and line do not intersect each other. Okay, so this would be the third case where the curve and the line will not cut each other because the discriminant is a negative discriminant. Alright, so there you have it. We have an example of how we can actually use this to also determine whether we have any intersection points at all.